Hello and welcome to Numeristical. We've reached the end of the regular season. Congratulations to the Mets who managed to sneak into the playoffs, and good luck to them as they face the Brewers today. And thanks to all of you who have been watching during the season and following along. As promised, I wanted to spend some time reviewing the performance of the models and see what we can learn, see what interesting tidbits come up. So let's jump right into that. So we're going to review the totals model today. That's sort of the good news. This is the model that did the best out of the three that we had. And we're going to dive into some details and see where the model did well, where it did badly. So first thing I do is loading in all that bet data, both for the money line and the totals. And then I'm just going to pick out the totals. So here are all the totals bets we had for the season. There were exactly 200 bets over the course of the season. And you can see 140 of them were unders, 60 were overs. And here were the results. We had 102 wins, 86 losses, 9 pushes, and 3 rainouts. And we ended up almost exactly 10 units. If you were watching the last few days of the season, it looked like we were up 11 units, but then when I was going through the data, there was one loss that I had labeled as a money line bet, but was actually a totals bet. So we actually had one more loss than we thought on the totals bet, and one fewer loss on the money line. So anyway, the result is that the totals model was up about 10 units for the season. And that's pretty good. Over 188 decided bets, getting rid of the pushes and the rainouts. That means our ROI was 5.3%. So every time we placed a bet of, let's say, $1,000, we sort of, on average, won $53. And you can see our winning percentage was 54.25%. And the average bet line probability, so the average implied probability of the odds that we bet against was 51.56%. So roughly speaking, if we had given the set of odds that we bet against, the distribution of those odds, we had to roughly win about 51.5% of the bets to break even, and we won 54.25% of the bets. So we ended up 5.3%. So if you look, 5.3% is roughly twice the difference between these two numbers, and that's as it should be. So what else do we see? We see the overs. Now focusing on the getting rid of the pushes and the rainouts, we had 59 overs and 129 unders, and you can see most of the profit came on the unders. And we could dive in a little deeper and look at the specific bets. So over against different points. How did we do? So you see that on the overs, most of the bets were here at 7 and 7.5, and that's where we did the best. We actually didn't do too well when we did sort of the bigger number overs, even though the model picked it. So that's interesting. And we kind of see a similar pattern over here with the unders, where these 8 and 8.5, we didn't do too well. But on the 9 and 9.5, we did quite well. And then these extreme ones were roughly a wash. And again, all of these are small numbers, so you have to exercise a lot of caution in sort of reading too much into any of this. But it's sort of interesting that the 9 and 9.5 unders did better than the 8 and 8.5 unders. So if you were watching closely over the course of the season, you might have noticed that at the beginning we were picking a lot of overs, and then at a certain point it switched and started picking a lot of unders. And that was not a complete coincidence. It was I did change the model at the end of May. So I changed the model, and I think I actually found some, like a little bug or something that was causing me to pick more overs than unders. And previously the model, if you looked at, for example, the model that I built in the 15 video series, you saw I was picking mostly unders. So that's what I was expecting. So then when I found like when I redid the model and said, oh, I think this is off, and then it started picking more unders, I thought, oh, okay, this is probably right kind of now. So so we might even just sort of take a look at how we did on just the unders, or how we did, from June forward. And you see from June forward, we did pretty well. June was a very good month. July was profitable. August slightly unprofitable, just a touch, and then September was again a little bit profitable. So anyway, so that's some other lessons learned here. So again, breaking it down on the unders, we were 71 and 58, and we were up 9.25 units, and the overs were up 31.28, so really just over 500, and just enough to cover the vig plus a tiny bit of profit. Okay, next up, let's dig into who were the home teams that we made and lost the money in. So this kind of tells us both teams that we bet on unders a lot, but then specifically also tells us a little bit about the stadiums. So you see, when the Angels were the home team, we bet 15 times the under, and we were up 6.3 units. So that means we were probably like 11 and 4. So up 7 units minus the vig, puts us down to 6.3. So that was interesting. This is the one that really jumped out to me, though, is the Cubs. So if you're watching over the season, you notice there were a lot of times when the model said to pick an under on the Cubs, and I'd look at the weather and it would say, well, the winds are blowing out at Wrigley. And I'd kind of give some caution, but often would say, I think I'm just going to stick with the model. And I'd go ahead and pick the under. So 7 times I bet Cubs unders at Wrigley. And from these numbers, you can see it was 6 and 1. So again, very small sample, but part of the reason I'd done a little bit of analysis, I'd done some back of the envelope calculations, and thought that I think, the odds were kind of overreacting sometimes to these wins. And so again, I wouldn't conclude anything with a lot of certainty, but this gives a little bit of evidence to say that perhaps the bookies overreact when the winds are blowing out. And I think there's a big difference to like just how strong those winds are. If they're like 20 miles an hour, that's a big deal. When they're like 12 miles an hour, I think it's maybe less of a big deal. But again, this is kind of speculation, but it was interesting to see that on those Cubs unders were quite profitable. And then what else do we see? Twins overs. This was sort of interesting. These were obviously mostly early in the season. And I don't really have much insight on what was going on there. And again, these are small numbers. The other one maybe is the Reds. The Reds unders did well. Now what did poorly, which teams at least, not a huge, there's not a lot to say because no other team had kind of more than 7 bets. The Dodgers unders, you see, we roughly broke even. We bet unders 13 times. The Nationals unders, we bet 17 times. Again, kind of not significantly one way or the other. Now this is as home teams. Now if we go and we just want to look at like what teams did we bet overs and unders on, and you see the Angels we bet a lot, and we're pretty profitable on. So betting, the model liked to pick unders on the Angels, and it did pretty well. Interestingly, the Mets also had a fair number of unders, and was reasonably profitable. The Nationals we bet 20 times the under, slightly profitable. And then if we go, who are we losing money on? You see the Dodgers. So the model seems like it was to some degree underestimating the firepower of the Dodgers. So 21 times we bet on the Dodgers unders, and we lost 7 units on those. And interestingly, the Giants, We did poorly on Giants unders. On just 12 bets, we lost 6 units. So that's not very good. So again, I know Dodgers make sense, right? So Dodgers were kind of a quite a good hitting team, one of the best hitting teams we've seen so far, and for whatever reason, the model perhaps understated their firepower. Okay, but now let's try to answer the question, like how significant is this performance? Can we can we take this model to the bank and say, hey, we're definitely making money. We're definitely, statistically significant, so to speak, that this model is better than the bookies. Or could this have been just luck? So let's try to get a handle on that. And if you saw, I did a retrospective early in the season when the model was doing pretty badly, just to try to get some sense of of whether I was just having bad luck or whether the model was really fundamentally flawed. And just to review some of the approaches I took there, we're going to think about a few different probabilities. There's the betting line probabilities. That's when you just take the odds that you bet at and convert it into a probability. So the implied probability of the bet you placed, if the true probability of the event equals the betting line probability, you will have a 0 expected value in the long run. If the true probability is greater, you should have positive expected value. And if it has less, you'll have negative expected value. So this is like the number you need to beat. This is the number you're betting against. Now there's also like, what does the bookmaker really think the probability of the event is? So remember, the betting line probability incorporates what they call the VIG. So the difference between the bookmaker belief probability and the betting line probability is the so-called VIG. And we don't really know the bookmaker belief probability, but we can kind of guesstimate it. Because, for example, usually in NFL games, for example, when the bookies think it's a 50-50 bet, they'll usually make you bet minus 110 on either side. So that means that their VIG is about 2.4% on each side. So when they think it's 50-50, they make you bet it at 52.4%. So we can roughly, this is kind of crude, but we can roughly say, hey, we're just going to subtract 2.4% and say that's probably what the bookie really thinks the probability is. Then there's our model probability. That's like the actual number that came out of the model. But again, I want to emphasize, I don't expect the model probabilities to be right. And what I've seen is that when there's a big discrepancy, so if the model thinks something is 60% and the bookie thinks it's 50%, and so therefore, I can bet at 52.4%. What I found from backtesting and what we'll see here again kind of is emphasized is it ends up being about 55%. It ends up being about halfway between what I estimate to be the bookmaker belief and the model belief. So the model doesn't need to be kind of, when the model says it's 60%, if the reality is 55%, that's kind of good enough. That's good enough to make money. So that's why I come up with this sort of adjusted model probability, which is saying, based on backtesting, when I see the model's probability and the bookie's probability, what do I kind of personally think is probably going to happen? And I kind of guess it's going to be somewhere in the middle. So what I did was, let's walk through this example. So for example, if the bookie thinks it's a 50-50 bet, the bookmaker belief probability is 50%. To bet the over the line is 110, so the betting line probability is 52.4%. I run my model. My model says it's 0.6%, or 60%, sorry. So the model edge is 7.6%. And then when I did this back testing for the totals model, it said 7.5% was about the edge you wanted to maximize your profit. So I would have placed this bet because it would have been over my edge, and then, but I would really expect it to win 55%. So I would put in what my sort of, what I call the adjusted model probability is just 0.3% more than the betting probability. Okay. So let's do some evaluation. We're going to consider two scenarios. We're going to say, let's say the bookie is right. What's the probability? What's the likelihood of all the bets that we've seen under the bookie model, the bookie probability, and the adjusted model probability? And let's see which one has higher likelihood and by how much. So this is how we do it. We say we think our edge, we think the sort of model adjusted probability we get by taking the betting line probability and adding 3%. And we get the bookie probability by taking the betting line probability and subtracting our estimated VIG, which is 2.4%. So we create those probabilities and then we compute these likelihoods. So first, simple thing, we won 54.2% of the time. Based on the betting line, we should have won 51.5% of the time. Sort of guesstimating what the bookie probability was, we would say they think we should have won 49% of the time. And the adjusted model probability, so this adding 3% to the betting line probability, you see was 54.5%. So we were very, very close to what the adjusted model probability was. And if you now compute these log losses and then convert this to a likelihood ratio, you see that the data was 2.64 times more likely to happen under the adjusted model probability than under the bookie probability. And what that means is that if you started out thinking, I don't know whether I should believe the adjusted model probabilities or the bookie probabilities, I think it's equally likely that either one of those is the right one. After you saw this evidence, you would kind of say, now I think it's like 73% confident that the model probability is right, the adjusted model probability is right, and only 27% that the bookie probability is right. Now you could take a look at this again and say, well, I adjusted that model after June, right? I had this model that was picking a lot of overs. Clearly, I changed the model pretty significantly at that point because all of a sudden it started picking unders. What if I just looked at June forward? And you see, it doesn't change that much. It's the likelihood ratio is now 2.7. And instead of 72.58%, I think it's 73.05%. So again, 73%. It's not changing what we thought that much. So either way, we kind of think the data is about 2.7 times more likely under the adjusted model probability than it is under the bookie probability. If you start out thinking 50-50, you would have thought, after seeing the data, you would have thought 73% that the model was better. You started out, let's say you start out kind of thinking, well, the model is probably right, 2/3, 1/3, let's say. Then, so if you thought it was like 66.7% that the model was right, now your belief would have changed to 82.5%. So again, some evidence, but not like, totally convincing evidence, right? Now, I had done this privately around the All-Star break when the model was doing quite well. That was kind of a high point for the model, was the All-Star break. And it was actually a little better than this. It was like the likelihood ratio was about 3 at that point. So that meant if you were 50-50, you would have gone to 75%, and if you started at 2/3, 1/3, you would have been sort of 90% confident. But the performance after the All-Star break was kind of middling, and so we didn't really improve that much. And again, 188 bets where you're comparing, 55% to 52%. You really need a lot of data to show the difference between 55 and 52%. And so, just having 188 bets that were really exactly at the model probability, kind of on average, still only gives you a small amount of confidence. So I thought that was interesting. But I'm going to stop there. Thank you for watching this. I hope this was enlightening. We'll do another retrospective soon where I'll look at the money line model, and we'll unpack that and specifically get into some of the questions around the model picking a lot of underdogs and the White Sox specifically, and how much that helped or hurt us. So stay tuned for that. I hope you enjoy this. Have a great day, and I'll see you in the next video. Bye-bye.